This is what? Periodic. Okay, what does it mean by periodic? It means that IT plus capital T is equal to IT when this one is a fundamental period. So actually, for this type of the sinusoidal, the period is equal to what? One cycle, 360 degrees, right? Okay. Okay, and then it said sinusoidal function is distinct. Okay. Okay, so this one is just like, oh, no R. Okay. Sorry, no R. DISTINCT. Okay. Distinction. Do you know the word distinction? It means that it have only one. Okay. So because the sinusoidal, the parameter controlled by omega or the frequency, when you have a different frequency, the shape of the curve will look different. Okay. So that's why it said distinct. Okay. So it will look different. Okay. Okay, so it will look different when it has a different frequency. So when you change the frequency, okay, the curve look different. The reason why we start with the sinusoidal function, because we believe that, okay, any signal can decompose to a sinusoid, so many different frequency of sinusoidal. Sinusoidal having the different frequency. Put it that way. Okay. Well, and then the next property of the sinusoidal function, okay, it said when the frequency f is increased, okay, you will increase the rate of oscillation. When the frequency increase, you increase the rate of oscillation. What is the word oscillation mean? It just repeat itself half. Okay, so that's oscillation. Or when you look at the clock that have a pendulum, okay, it just swing back and forth. That is oscillation. Okay. Now, in this class, because our quantity will have a unit, and the other thing that we should keep in mind, everything have a direction. Okay, so when you try to define the current in the circuit, you must put the direction and the quantity. They go together. Okay. So when you definition of the current, okay, okay, so this one have direction plus the value. Okay, you have to have direction and the value. Okay, for example, you have something like that, and then you said, well, the current, okay, you will say, well, this one you can say this is 2 amp, okay, or you can say for this one, you can say this is minus 2 amp. These are equal. because the current flow this direction, the quantity is 2 amp, okay, and this one said minus 2 amp going this direction, so it's actually the real one is opposite, okay, so both of them are the same, okay, look different but they mean the same thing. So it means that for both of them the current flow from point A to point B, okay. From A to B. Okay, before we leave this one, let's see, okay, if you have, for example, if you have something look like this, okay, that's 10 amp, and then this is IT, and then this is a T, okay, you have 0 here, you have 1 here, and then you have 2, 3, and 4. The scale may be a little bit off, but that's okay. Okay, yeah. Q is equal what? If that's given, okay, this is given IT look like this one. What is the Q? 10 amp. This is 10 amp, and then what is it? So the Q will equal to integral from 0 to 4, right, of IT dt, okay, and then to the 5 from 0 to 4, 35, or you get 35, okay, you get 25, you get 35, so what is the right answer then? $35, $25. What did they have? I have 25. Oh, okay, we get. Oh, we have to go faster than this. Well, the answer is 25 coulomb. The second one, the second quality, it will be the voltage. I will go a little bit faster than. The voltage, okay, what is the voltage? Now the definition of the voltage is, what is it? The potential. Okay, the potential difference. Okay, potential difference of what? Of the voltage. The potential difference of charge. Of the current, charge and current, they are the same, right? But they're not really exactly the same. But charge and current, charge now we have potential. What is the voltage telling you? Well, for example, okay, the voltage is something you said potential difference. Okay, when you have a potential difference here, okay, so now when you try to measure the quantity of it, okay, so you can say that this is higher potential, this is lower potential. What make you think that, what make you tell me that this is higher potential and this is lower potential? What is the value that's telling you? Okay, when you try to, because when you have a potential, you will try to move the electron. Think about the electron flow from the electron flow from the low to the high, right? So actually the electron move from down here to the up, to the top here, okay? But the current flow from the top to the bottom. So what you're trying to do? You try to push the charge going up, right?